Remove boxes. Okay. Given several boxes of different colors represented by different positive numbers, you may experience several rounds to remove boxes with no boxes there. Choose time you can. Choose some container boxes of the same color, composed of K. Man, K. Remove them and get K times K points. Find the maximum points you can get. Oh my god, this is one of those problems. Okay. Let's see. So in this case, you remove. Let me read this again. That was slow. Given several boxes of different colors, for example, different positive numbers. So you keep on removing boxes, and okay. Why is this still trying to? Okay. So first remove the twos, and then you could remove the threes, and then you remove the four. Oh yeah, you move the 4 for 1 point. Man, this explanation could be a little better. And then use 3, and then 1s, and then 0. Okay. I mean, it definitely is a hard problem. Let's see, what can I do? I mean, I think my intuition is that this is some kind of recursion problem. So it's likely dynamic programming, sadly. What are the subproblems, right? The subproblems is what happens with for index from 0 to n. So you're trying to optimize what's the most points you get from 0 to n. And the most point you get from 0 to n is just the sum of the subcomponents from so it's from 0 to I, and I plus 1 to n is the optimal, and where you draw that divide is the number of subproblems, and there's a lot of repeating subproblems in that. I mean, up to n squared of them, and n is just 100. So, and anytime you get a subsection that only has one color, then you could just return that. Otherwise, which takes account the one case as well. Is that sufficient? Let me think about this. Is that good enough? No, I mean that's one way to. I think what I'm trying to figure out is a better way to construct subproblems. And so basically, what you have is you start from. I mean, it's roughly right, but there are ways to kind of split the problems up. I think what I said earlier, into dividing by halves, may not be accurate if like, for example, like for this case, like for the case where I have to read, like that's an example, something like that. The way to think about it is, a lot of decision problems. My other I'm also trying to think like what are the, so there are some numbers or colors, I guess, that we have to try to figure out. Are there more than two-dimensional subproblems? Because for something like this case, you can't really divide them in any reasonable way because, well, this would give you a 6. You have to somehow figure out, like the merging is not super intuitive to me. And then you have something like this where you have something like this, then what are the subproblems here, right? The subproblems are you first remove the 3, and then you get the 6 of them, which is 36, which is already way more than how, like, which is clearly better than 3 times 3 times 3, because then you have, or sorry, 9 times 3 is equal to 27 if you do it like, take a, but if you just remove this, you get 1 point plus 6, so that's 36 plus 4, so you got 41. So that's quick. Also try to think, I mean, I think dynamic program will kind of lead us to the right direction, or memorization, but I'm trying to think if there are, trying to think about the like, what is the best way to split this up. Man, this is indeed a hard question. Well, let's think about this a little bit. What I'm thinking now is like, is there like, you have colors. Is there an analog to a graph problem that I can kind of take advantage of? And clearly the point incentive system is non-linear, but it's so there's definitely a thing where like you're definitely incentivized to get more boxes, but is there a point in which yeah, but yeah, there, like 2 sets of 5s is better than 1 set of 6. And how does the greedy work? Greedy probably doesn't work. It doesn't sound like you could just, How do you solve the subproblems? Okay, so I think what I would think about is think about in terms of rounds. Maybe it's an n cube dynamic programming where is there 3 states, or maybe not even 3 states, just 3D states, but 3D n cube time. But I think for each round, can you be greedy each round? Because in this case, you can't be greedy in either that. Like in this case, let's say we pick 3. Oh yeah, no, but you actually need to remove the 3 and then 2 and then 3, right? So there's no like ordering that, so I mean, or like the ordering matters. So you, and yeah, and you also get to a thing where the case that I'm trying to figure out is like, well, like something like that where you have like a sandwich, and the ideal move is just to keep on taking stuff from the middle. And you may even imagine a weirder case where something like that even, right? We're like, well, what's the ideal case here? Probably to get the 16s and get the 1s. So then in this case you get the 3 1s plus 16 as you go 19. Oh, typo. But can you do better? Plus 3 is 9, so no. Like, does it always make sense to be greedy? can you prove that greedy makes sense in each subproblem? And let me think about that. Okay. Probably the thing I'm trying to think about is like going back to the older example of like, maybe I just don't do commas. How do you represent this as a subproblem? Or like, what is the subproblems here? All right. Well, the subproblem is just do all the twos. But then like, if I had something like this, what would change about it? And clearly you can't do some kind of 2 to 100 thing because which is the number of possible states, just because there's binary whether you remove them one or not. So that's a little too much. But in this case, you would still remove the 3 first. But then what if you have, I don't know, maybe it's a bad example, but or something like that. Do you still remove the 3 first? Yeah. Oh, I think colors with different positive numbers. They just, I think yeah. I mean, it's not, I think I don't have all the understanding I need, but the merging step is a little tricky. I'll look at this example and see what I can do here. I'm trying to convince myself also that maybe it doesn't matter. Yeah. I think for given subproblems, try to figure out like, okay, but we're greedy, that's fine. Okay, I think I have a better way to think about it. I think what I've been thinking about is kind of from the beginning to end, where like, okay, my next move is to press this button, and a lot of in a lot of memorization case, maybe that makes sense. But I think maybe the question, or I'm just trying to think about it from a different angle, where maybe the question is, well, what if I press this color last? Does that make sense? I say this case, I'm gonna well, I want to press the 2's last, then I would have this case, but I would move the 2's last, but then what would I have to do to remove the 2's last? Well, then I move the 3's. And then maybe the subproblem is just this, because you want to remove the 2's that are inside. And then still trying to figure out like if there's a clever way to kind of do the merging, or am I just thinking about it too much? But like, is it easier than I think it is, or am I just doing the weird? Man, that was box size. Okay. Yeah, I mean, I think I'm going to give that a try. I mean, okay. Yeah, I mean, okay. I mean, I think I've spent way too long kind of thinking about this, but I think like if this was an interview, I would definitely like commit to running any kind of code as soon as I can, and then figure it out. But I think I'm missing a dimension somewhere. But oh no, is this thing on? Yeah, click on the one button. Oh no, it's here. Okay, I just minimized it. Worried about moving the stream somehow. But okay. Yeah, I mean, I think, yeah, I think I'll just go on and then see what happens if I remove all the. So there's left, right, and yeah, I mean, it definitely feels like an n cube memo thing. Just left, right, but then what is the third dimension? Anything with colors? What? Try to also think like, well, I mean, are these just unique, different positive integers? I guess that's fine. I mean, I guess it could go up to any number. At some point, I mean, and I think the numbers don't really matter in the sense that you could just re-index them if it matters in a weird way. But Huh. Does it matter? Mm-hmm. Left to right. Okay, well, let's just start coding something. Yeah, I mean, I think I've been usually I don't really commit to code before I have a general idea of what I want to write, but uh, I think I'm spending way too much time thinking. So let's go. Okay. Um, hmm, okay, I'm still a little bit used to this uh, 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 thing. So let me see if I could do. I don't know what I can do and what I can't do. So let me just. Is this rather Leetcode code? Okay. Can I do something like just to clean this up a little bit? And again, I choose 105 because I think the max is 100, and I. Okay, so that looks like I could do that just for fun. Okay, so I don't know the boundary of what I can and cannot do, but okay, well, and and I think like in real programming, you just have you actually like manually set they give you boxes sizes, so you could manually set it, but I'm just too lazy. And now I'm just I think so. Another kind of if this was like a programming time test thing, well, one is I'm already way too late, but way too slow. But also I would do something that's like what's it? So something like that actually works, but I think just to pretend at least to be slightly cleaner, this is what I'm going to do. So so it matters generally what you put as like the standard default value. In this case, I chose 0 because we're trying to maximize the score, and I don't think there's any way to, no, there's no way to get negative. So what you want to do is yeah, so there's no way to be negative, so 0 is the minimum score, so that's like a good kind of base scenario. And I think and it's just construct this goes by random name. I'm so used to just typing name function name go for a lot of stuff, but let's just actually change something. Okay, get max score, say yeah, okay. Oops. Size and maybe and box size -1. Okay. Okay. As for what K is, to be honest, I don't know yet. I think I have some intuition about how I want it to be, but yeah. Let me think about it. My question is, okay, well, okay. I think what is K? Well, first of all, well, let's just get rid of the memo thing. If it's greater than 0, it should be actually by just not 0, but that's fine too. Then we return it. Oh my god, can't type right now. Oh my. Okay, so that's the programming part. There's probably another base case. If is that a base case? If maybe something like that. Generally, yeah, I guess it's greater than, because if it's equal to, it could still get 1 point. Let's just return 0 here. Okay. And what do I do now? Okay. Let's say I try to. I can actually minimize this a little bit. Okay. I think what I want to do is, well, given this subproblem, we'll just take stuff off the front. Does that make sense? That was K though. Oh, I guess the way that no, if we only take the last or the first K characters and then or okay, so I think what I want to think about it is now, let's say I only process the first, so K could be the number of characters to scale that's already processed. So okay, so what does that mean, right? Okay, what that means is, okay, let's say I have this subset. I'm going to take out 1, and that's the sum of so right now we're in nothing but scaffolding given as I. So what does that mean? How do I solve this? So the left is equal to 0, right? And then that's equal to 1 point plus 2, 2, 2, 2, 3, or solving this subproblem. Oh, I guess I would put that. Yeah, is that or I guess the alternative. Oh, I guess that's just the base case. The alternative is chain them. Okay. How much can I chain them? The other one is 3. Well, you want the end state to be 3, not end state, but intermediate state. So I don't know how. I mean, I'm drawing it pretty terribly, but what you want to do is do you want to solve the subproblem of this plus 3, 3. So Is that sufficient? Can I just iterate through that? Okay, I think I am messing up a little bit. Okay, so what I want to do now is, okay, I think I got it. It's taken a long time. So the subproblems here is, okay, I think I got it. So, I mean, I think all these things that we're talking about, all the concepts that they're kind of what we want, but I think we just kind of need a clever way to kind of schedule the subproblems in a way that is exhaustive, right? So I think that's the only tricky part. I think the thing that I kind of took I mean, some intuition about it, but I think I was trying to kind of get around it, but unsuccessfully, clearly, is that, for example, in this case, I think what I want is, so, I mean, I have some intuition about it being 3 dimensions, and it's right, but I think what this should be is kind of, it's like ongoing, maybe that's not the right word, but it's the number of the same digit so far. So in this case, same, maybe that's fine. So in this case, if we say we have, let's say we have this, then the subproblems would be, well, let's take let's take one subproblem in particular, because that's the one that's a little, well, so let's just take let's skip the one down. So let's say you have this. So at each decision, this is just, well, at here you have decision, right? You have, given all this, the decision is whether, so you want to, how do I say this? So, well, you know that the 3 and the n matches. So now you're just solving this subproblem where we can use a 3. And there's some, yeah, I think that's right. I mean, I think that's even an optimization, really. So you just solve this subproblem where, okay. But then you have to keep track of last. So, because then in this case, you would, the parameters, well, this is represented by left, right. So, but, so the subproblem would just be this plus you last use a 3 and you use one of them, right? So I think maybe another way of representing, and but in that case, you would, so yeah, I mean, I'll just type out a little bit of first. I guess maybe this is streak. Maybe that's a better word now. Now that I'm getting over it. So you could have like last digit or something, right? I mean, so, and then you know all the DP would follow through, so you have an n to the 4th. you have an n to the fourth dynamic programming, but 10 to the fourth is 100 million, and that doesn't even count the number like mini loops. But I think if you always you take the invariant of always assuming the first digit, so yeah, in this case, I think how I could construct it instead of what I just did, instead of that, instead of this, like we construct it as if I encode that 3 as the within the left part of the array, then maybe we can use what we have now, which is n cubed. I think maybe that will go okay. Okay, so I think what I would do is, okay, so the base case for something like this is, well, let's just say we eliminate everything, right? So I guess that's the base case. So you say, how do I do it? Okay. Like something like right trim. So what I'm trying to do is, well, oh, I guess this is equal to right. It's like, well, given this, let's just trim the right as much as we can. Let's say we have this, right? Then you just take 3 off, right? So, okay. So, well, left is less than right. Oh man, my iWatch is telling me to stand up. Okay. And oh man, I forgot to. This is a little bit hacky for now. In theory, we could just pass in the get max score, or if you have like an OOP type thing, you know, that'll be part of the invariant. But yeah. So basically, this is just trimming the n, then right trim plus plus, and streak plus plus, I think, because then whatever you do in the middle, because I mean that's like the minimal base case in that yeah, what you do in the middle, and you could actually, yeah, maybe I don't even need this right trim. Okay. Okay, because I think so another, I mean, so you could do this for loop, and I mean, it's an optimization for sure. But actually, another way you could do it is another way you could think about it is just do another recursive call. So let's say the score is equal to get max score, left, right. In that case, it will increase the streak plus 1. Right. Okay. But this is only the case if p left is equal to p sub right, and in this case you do p minus 1. Okay. Okay, so that takes one thing off, and this is actually this plus streak times streak. Is that what? No, is that right? Am I being too dumb here? Because then in this case it will go streak plus 1, and then that will also increase the score. No, okay. Now I need this part here, because you really do need all of them at one point to get the points together. So in this case, max, which is the current max score, is equal to get max score, left, right trim, and also as I noticed, this should be minus minus. And now you have no more streak. maybe left plus 1. Do I do left plus 1? Is there? Yeah, I mean, let's do this for now. Wait, can I? Is there? Man, dynamic programming forms are sometimes, unless you're like really exhaustive, it's hard to prove to you. It's hard for me to prove for myself that, it's right. Okay, let's try this plus streak times streak. And now we do all the, as you can tell, actually there's not that much programming. A lot of it is just try to figure out what you want to program. So this resets the streak. Is that what we want? Yeah, it should be okay, maybe. Okay, now we're just looking into this set. I guess now I guess now you're trying to solve the 4, which is fine. So you, man, maybe even minus. No. It should take itself because then left is equal to right thing. Do I have to do left equals to right? I don't know if I need to do this per se, but I think it's just return a array and return a base case, just in case. I guess now you're trying to, your subproblems for this is, okay. We also declare a variable. Score is equal to get max score. The new left to the right trim. What is the streak? So basically I'm just dividing in chunks, but it only makes sense if it's here. Well, for 4 it doesn't really make sense for anything really. But let's say this was our subproblem, then we want the entire, well, if this is our subproblem, then we want this to see what happens if we take the entire subset here, and then maybe this to isn't it an infinite loop? Oh no, because then the next round we trim, and then you have this subform, and then okay. So I think this is about right. And this is why we keep the left, is because if man, this is a tough problem, and I ran out of water, so I can't even, but And does it make sense to subproblem? Maybe this isn't right. Am I doing the right trim? Maybe I, okay. Also, did I remove this? Okay, fine. But actually, I think what I want is a left trim. I think I've been confusing myself a little bit. So we want to trim the left. We're left trim. But I guess you just, okay. Let me try something else. So let's say I have this one of things, been mixing it up. I think what we would is now, okay, now I think I know what I want to do. So you definitely do the trim. So this, I think this makes sense now. I mean, I said that a few times, or maybe basically you get the max score of the trim times, because okay, so this now bases off the first letter or first color. So now, okay, because now this is already factored in, and now you oh, I didn't replace it to this, and now the thing is, you want to recurse on every iteration of the next of the same color. So like, so if I see this 3, then yeah, we recurse on this, and let's say if there's a 3 on the middle, then we also recurse on this, but 4. So yeah, so then you just always iterate on the next merge. Basically, that's all the possibilities, because you only want to solve the middle ones. The splits are in case of the yeah, the subproblems are like you only want to merge between the next 3s, right? And this will allow, this takes account of the case where we have nothing, or this takes account of the case where we don't even, we just hit it by itself. So in this case, we do 3, but okay, I think I have a better idea now. Okay. Oh man, actually, now that I'm thinking about it, it seems way obvious, but I guess that's the thing of dynamic program bombs. Sometimes it's tough. Okay, you start with left trim. What is left trim? Okay, just to make sure I get my indexes right. So left. In this case, this would, so when it ends, this is the first element. Okay, so then we can still do stuff where, okay, if well, with B left trim, oh, yes, you go to B left trim. That means if it matches the same as before, then I want to do that recursion on the stuff that's so then I would do recursion on this stuff and all the stuff afterwards. Okay, because so what this third dimension allow us is that when we solve this part and we go to this part, it allows us to continue that, carry that streak to +1, so that it solves for the case where you do 2s and then 4s and then 3s, which is in the problem. Okay, I think I'm convinced by that. So the left is I. The new right is, wait, trim I, and since they're the same, that's streak +1, plus get the max score on the right side, so that's I +1 to right. In this case, there's no streak. And then if score is go syntax a little bit, max is equal to score. Okay. So what I'm doing now is I have to recache the answer. There used to be a trick on here, but yeah, whatever. Okay, fine. What I'm trying to figure out is, do I use the new streak or the old streak? I guess I should use the old streak. Okay. But then I incremented here. That's what I get for mucking around with it, I guess. This is okay. Well, just actually seeing if it compiles probably typo somewhere or something. Implicit declaration of function. Okay, fine. Oh, did I forget? Okay. It is an annoying thing about C, I guess. 142. Oh. Go habits. Stack Overflow. Okay. Whoop. Okay. So the host is. Oh. Let me think about it for a second. So this n square shouldn't really go that much. I guess the thing that I think there's something wrong here in that if we trim off the beginning and it's yeah, I mean, I think I just don't progress this enough. I guess maybe this should be +1. So that it keeps on calling the same thing. Okay, well, I guess there are other cases as well. I +1 is equal to right, so it doesn't call the same thing twice. So what happens with a Stack Overflow when you do a memorization? It means generally you call the same thing more than once, and then it goes to an infinite loop because it should fit in this stack space. There's only n cubed. It is like, maybe not. I don't know. Yeah, that would be janky. But alright, well, let's just print real quick. Oh, yeah, it stacked overflow. Well, at least it tells me enough, which is 1.8. So it takes to 1. So what's 1.8? Let's trace this a little bit. So it's 1.8 and 0. I guess it must be 0. 1.8. Left trim. I said left. Oh, left trim has to be left. Okay. So hopefully that's why. But still unfortunate though. Okay. I mean, we're making progress. Obviously, it's not the right answer. So let's see what we can do. Let's put out this first. And then we can see how it fits with what we think is right. Just 7.8 returns score 2. I guess that's right. 6.3 sounds right. What's 5, 7, and 1, 2, 3, 4, 7, 1. Is that right? No, is that right? 5, 7, 1, 3. Well, let's do the zeros for now, but this is clearly should be. Okay, I mean, we could want an easier example just to kind of confirm our thing. Whatever. And I really hate that they show you the expected, just because I think you should be able to figure out by yourself what is right. I mean, no one's going to, especially on an interview, no one's going to tell you the answer or whatever. Anyway, 0, 2 to 3 points, is that right? I don't think so, because you should get 5 points, right? So, okay. So that's good that we actually found very quickly what, is this like the cheating answer? Anyway, what case is wrong. So why is it giving me 2? 2, so 1, 2, which is fine. But I think it just never goes into streak. No, I guess actually we start streak at 1 technically, or you get the points as wrong because oh man, because when you always take away at least 1, so that's why that should be. Oh no! Yeah, of course I didn't. 1 button. Okay, well, my perfect record by clicking submit early. Okay. Okay, so that doesn't seem like that's the reason. Oh, Do I need to add points here? Does that, No, it should be okay, but, okay. But 0, 2's no streak is 3. But why would it? So this takes up the. I think there's some off by 1 in the recursion, because I think what happens is that this looks okay, but I think here is not doing the thing where for 343 what we expect is that it takes this 3 and this 3 and then somehow we merge them. So so Let me also just see what the left trim is. Maybe I'm off by 1 on the trimming. Okay, so it actually doesn't do any trimming, right? And is that right? So this part is probably right. But this part we get itself. We could do 1, 0, 0. So maybe this isn't right. The base case should be maybe streak times streak. Yeah, I did that to be lazy, but I don't think that's sufficient. Maybe it is. I don't know. So that's actually even worse. So there's a couple of things wrong here. I think on the logic we're roughly right, but there's some definitely off by 1 issue. Man, this is a very tricky question. Okay. I think I have to consider this case more. Okay, let's actually, I think maybe we don't need that case. Nothing best turns out. Okay, well, we're making something. I don't know if it's progress, but okay, but it's this. If it's the same character, you get 1 point. If it's the same character with streak, you get 4 points. I think that's good. 1, 2 with no streak is 5 points. Why? So that means it's 4, 3 with 0. It gives you 5 points. I think something's because 4, 3 with no. Okay, I guess in that case we could even simplify the formula even more, or the input. This should not take that long though. Then you could sell to change up. Okay, so I mean, yeah, so we definitely made some progress in even the user symbol case where this is just clearly wrong. So I mean, so that's good. Yeah, so I don't think we need left trim for now, but 0 to 1 is 5 points, which is clearly wrong. So there's an off by 1 on the streak somewhere. That's probably giving a 2 streak. So because I print, one thing to know is that because I print at the end, these are actually last in, first out, first in, last out. So 0, 1 calls 0, 0 first, and with 1 streak. Oh. Okay, I think this would have been okay. Okay, I think that I just have 2 cases that is a little weird. So the edge case is that if I, if I is left trim itself, then it should not get a +1 to streak, or because then this would already be 2. Is that right though? Why is streak 0? Hmm. 0, 0, 1, 4, but okay. Trying to think, man. But why does it have a streak of 1 already? Oh, because of this. Oh, but that's, oh, I see. So this is, this calling this is fine, but then it messes up with this. So I guess I do need that base case, but I need to do that more cleverly. Because the streak is, because it recurs with the streak being 1, and then now here it gives 5 points. So, okay, well. If left is equal to right, then I mean, so why doesn't this work? Because most of the streaks are 0. So if left is equal to right, then maybe I just need to set to 1. No, this is a okay, fine. I think this should be okay. I think I just need to do something like, okay, well, let trim plus 1. Yeah, I think this actually takes care of the left trim, so I just need to start from left trim plus 1. I think I'm splitting the cases up. Okay, so that works for that case. But, you know, spend like an hour on this, so still not confident about it, so let's try this one. I think what we expect is you hit the 4 and then you hit the 5. You hit the 1 and then 2, so then it should be 5. But clearly this is not working still. What's some of the weird edge cases? Grumble, grumble. Okay, I mean, I don't think we need a left trim here for now for printing it. It's making it slightly more confusing to debug. Left, right, so no streak, that's fine. Okay, so it does everything one by one, but does it do the case where we want it to be, which is we want I to be right. And right is, okay, so I think we need a equal sign here. No, well, that's not right. Oh, well. Trying to think. I mean, I clearly there's some thing wrong with the right part, but what's happening is that we're not taking the case where I is equal to right in some way. So then it doesn't. But what happens when I is equal to right? There may be some recurse or like off by, because then left trim. Oh yeah, because you have to do left trim is equal to. No, you can't do this. Only we're missing one case where no, that's not. Is that what? I mean, we are definitely missing the case where I is equal to right, but what happens when I is equal to right? Well, like, is this the case when I is equal to right? No, because, but then if I is equal to right, then it just recurs the same thing with the streak plus 1, and then you get some recursive thing, which is why it goes out of bounds. And these over ones are tough. I mean, I think we have the right philosophy and strategy. I think we have to try to figure out where the error is from. Because right now it's going 0, 2 to 1, 2 to 2, 2, which is, what is it? But it's not, because what you want is, you need I to be right. Do I need I to be right? So this is the case where you press the button in the front, or switch up the cards in the front. We need a case where it recurves the middle. I see. Streak plus 1. What is streak? Streak is 0, but in these cases, I think what I know, maybe not. I've been saying that a lot. In this case, streak should already be at 1. I think that's maybe why. And then, because once this gets matched, so this takes care of the default case. When it gets matched, it should already be at 2. Let's see. Well, it's just not calling streak. Well, this should, oh yeah, maybe this should be right now. No, I think I just need to represent it better. But if no, well, maybe I minus. Does that work? Well, there's more progress. Is it? Oh my god. That's crazy. There's an off by 1 somewhere, but at least now it's doing 1-1. But with a streak of +1, but or 1 with a streak of 2, but it's not. So this is a streak of 2, 0, 1. Oh, I see. I cannot set this to 1, but maybe I meant this. Oops. So that seems a little awkward. Okay. Well, 0, 1, and 2 gets 10 points. But why? Because this gets added twice. Oh my god, this off by 1. So what's happening is our base case is a little weird. I mean, this is not going to work, but so I think this is because basically you want to increment it only if streak is 0. Okay. I feel like right now this is very hacky. If streak is 0, we start a new streak, so streak is equal to 1. Okay. But even if this is right, I'm so not confident about this as a result. I think there's a thing we should set default to. Oh man, it's taking a long time. We got the right answer there, but I think I mean it's one of those things where also I mean I guess we'll submit it where I mean it seems like a complicated enough case that it requires right, but this statement also just means that there's some like I think yeah I mean there's some reindexing that would make this cleaner, but well let's see, let's submit it before we and see if it works before we okay, so that finally worked. That took over an hour or something like that. It's very unfortunate, but at least now we finally got it. And probably spent about half an hour on an well a couple of off by 1 hours, but okay, well I think that will conclude my first